Okay, so today we are talking about Pub 229, the full site reduction. So by the end of the day / evening tonight, we're going to do the full site reduction. So we've kind of been working on parts of it, and then our homework assignment goes into steps on how to plot it as well. So we're going to do some plotting and the full site reduction form. And then our last question on our homework is a full site reduction form for 4 stars. So it's a full fix with 4 LOPs, which we are not going to have time to do tonight, but I will post the homework tutorial so you can watch me do the whole thing. Okay. So,
by the way, today,
yes.
So on the answers for today's assignments, it says see the plotting sheets.
Yes.
But there was only one plotting sheet. Is that correct, or were they supposed to all be posted, or am I looking in the wrong spot?
Let me check. They should be there. What are we doing? Answers. So that was the start. Oh, there's only 2 there. Okay, I will post. I'll do another scan. I don't know why.
Okay.
Thank you. Okay. Okay, let me make a note of that. Answers. Okay, can everyone see the PowerPoint?
Yes.
Did I mess up the share?
Yes.
Okay, we're good. Okay, so as a quick little review, this is our standard site reduction form. And I'm saying standard, but I'm just meaning it's for the sun. That's kind of like our basic one that we build off of. And we have the first part is navigator's info, second part nautical almanac, which now we are all masters at, and then we get to Pub 229. So that's what we're going to be working on today. The 2 things that we are getting from Pub 229 is HC, so that means it's the altitude calculated, and then Z and ZN. So that's kind of that's the azimuth of the body, kind of the bearing of the body. So when we plot something, we need 3 things. We need the assumed position. So we have our latitude and longitude, and we get that from our nautical almanac section. And then we need our azimuth, which we get from the Pub 229. And then we need our intercept. And our intercept is the difference between HC and HO. So it can either be kind of like a positive or a negative, but it's just the difference between our calculated using our assumed position and what we actually saw. So we have, I wish I had the other one. We have an assumed position, then we have the intercept, and then we could plot the LOP. I don't have the slide with the big circles on it, but hopefully everyone remembers. Okay. I just went over that. Okay, so in Pub 229, if you look at it, you could open up and look at it. We are given 3 columns in each column, if you will. HC and then there's a little D, and then there's the Z. So the HC is our, things all messed up. The HC is the calculated altitude, and the Z is the azimuth that we're then going to convert to ZN. So these are the two columns that we're looking at, and how to find
Ray, sorry. Question.
Yeah.
I'm in the PDF version, Pub 229, Volume 2. It says site reduction tables. Am I in the right place?
Yes.
Okay, well, the first thing I'm seeing is an interpolation table that doesn't look like this. Where am I supposed to be?
So go like halfway through, like
Oh,
scroll
is there a
halfway
certain-
down.
Okay. Is there a page number or something you're on?
171.
Thank you.
Okay. Is that what my example is here?
Yes.
Okay. I will have it out too. Okay.
Well,
So let me, now that I have it out. So here is 229. And so on the book, we have LHA on each page number. So if you flip one, we get an LHA of 277. Flip another one, LHA 278, 279, et cetera, et cetera. So every LHA is on a different page. And then here is latitude, and in this case, it's the same as the declination. So our latitude is 30, 31, 32, 33. So the page number tells us LHA. These numbers tell us latitude, and then declination is on the side. So those are the three things that we're going to look at. Just as a familiarization here, these little rules, we have north latitude, LHA greater, LHA less than, Z equals something or something. So that is how we convert our Z to our ZN. So that tells us what our ZN is equal to. So you have the north latitude here and the south latitude here. Even if you're on this page, you can still do north latitude. You know, the page doesn't have anything to do with where those little formulas are. It's just if you're in north latitude and south latitude, and it's the same formula on every single page. They just repeat it for you, so it's easier to calculate. Okay. Let's go back to the PowerPoint. Okay, so those are the two things we are getting from our 229, is our HC and our Z. Now how we get there is interpolation. So now I'm not going to look at the book, and I'm just going to generally talk about what interpolation is. So it's kind of going back to some, I don't know, high school math or something about how we interpolate. And we interpolate on the daily basis in our head, mental interpolation. But we're going to put it down on paper is a full-on calculation. So we have to kind of, what our mind automatically does for us, we're going to put down on paper. So an example, this is just a straight line example that if we were trying to find something, a value that was 2.5, we could see it on a graph that, I don't know, maybe it's 3.75 or something. You're kind of like ballparking it on a graph. This one had this graph had values in it. So this is the value of a car depreciating, right? So if I were to sell this car in, June 2005, so halfway in between 2005 and 2006, I use that mental interpolation, or you can do mathematical interpolation to say, hey, maybe I'd get $12,000, $12,500, something like that, to say I'm going to interpolate between the two given values. Sometimes the line isn't straight and we have a curved line. So that's called, a straight line is called linear interpolation, that it is linear and you can interpolate it very easily. When it's not linear, that's when we usually use a table or a graph in our case. If any of you have taken tides and currents with me, I use this kind of idea of interpolation with tides and currents as well. Again, this is more interpolation. What will the temperature be tomorrow at 11:45? We can see at 11, it is 76 degrees. At 12, it's 79. So we do this quick interpolation in our head all the time. But now we are going to do it mathematically. So this is my sandwich method, if you will, for those tides and currents people out there. If I put in the times, I kind of do a, one side is times and one side is temperatures. And I have a 60-minute difference on between my two large times, and a 3-degree difference between my temperatures. For my desired is 11:40, which is only 20 minutes. So I want to know what's kind of the ratio would it be for me to get to to find out what my desired temperature is. So that's my little X. So if I put these in a ratio, you can do 60 to 20 is equal to 30 over X. Quick little equation. I did it quickly with click my button. Then we get X is equal to 1. So if we were to apply 1 here, that would be subtracting, and we would get a temperature of 78 degrees. So we can quickly do that in our head, but we're going to do this kind of fractioning interpolation, and we're going to bring that sense back to Pub 229 of how in our time difference we're going to see the how things change. So our declination doesn't go by time. First I'm going to say, so we have 3 values on this page, right? We have LHA, latitude, and declination. We have 3 values, where before I was just looking at 2 values, time and temperature. But now we have 3, so we're kind of doing a triple interpolation. So triple interpolation is, I'm not going to say super difficult, but we would rather not do triple interpolation on every single time we look at Pub 229. So we use an assumed position in order to eliminate the need to do triple interpolation. If you are doing an azimuth, which we are not going to get to in this class, of checking your compass error, this is the table and the formula for doing an azimuth. We're not going to do it in this class at least, but we are going to make our lives easier and not do triple interpolation, we're just going to do it once, and that's if we use an assumed position. So, how we do that is our LHA and our latitude, we're going to put it as a whole degree. So it's not going to have minutes afterwards. It's going to be a solid 276 or 084. It's not going to be 084 32 minutes. Or latitude, I'm, you know, at latitude 22 degrees, 15 minutes north, I'm going to assume my latitude is 22 degrees even. I know that I'm not there, but I'm making an assumed latitude so that my calculations in Pub 229 are much, much easier, because I'm not going to do triple interpolation. I'm only going to do it once. And how we do that is by using a whole degree for 2 of the 3 values. So the 2 values that we use are going to be our latitude. So that gives us a latitude for assumed position. And then our LHA, which we can create an assumed longitude to get a whole degree for our LHA. And we're going to practice that on our homework. Does that make sense so far? Kind of.
Yeah.
Okay. Okay, so on our Pub 229 page, we have, I kind of looked at this, we have LHA on the page, then we have latitude at the top, and then our declination is on the side. If your declination is the same as your latitude, you're on the left side. If your declination is different than your latitude, you're on the right side. So the LHA is the same for the whole spread, the whole side of being your book being open. But then we don't have, you know, north or south, east or west. We just have contrary or the same. So that's if you're on the right side or the left side. And then they give us our HC and our Z, and that is going down. So that D right there is going to be the difference between this HC and this HC, and then this HC and then this HC. So how did it go from one to the other? That's going to be what that D is. It's just the difference between your HC values, so that you don't have to calculate it yourself. It's already given to you in that, that little D column. Okay, so this is going to be our interpolation formula, if you will, and this is part of our site reduction. So we go in with our first HC, and then we put in our little D, and then we get a calculated HC. And we're going to do an example of this. And then we compare it to our HO, which is what we calculated using the Nautical Almanac. And that's where we can get our intercept. For Z, they don't give us that little D. So I always write in the base Z and then the next Z, calculate the difference, and then I can calculate what my actual Z is. And then you use that little formula if you're in the north or south latitude to get what ZN is. Okay, so this is going to be our standard interpolation using 229 with our assumed position. So let me go to an example. I know I'm going through this really fast, but I think it will make more sense when I have numbers you can look at with me.
Okay, the Bree, just real quick, the rules that you're talking about, the north or south latitude, that is your assumed position. That's not the declination, correct?
That's, yes, your assumed position, correct.
Okay.
Okay, so our example is July 31st, 2020. We have a DR and we take a site of the sun, has a chronometer time and a chronometer error. Let's complete the site reduction form. So this is going to be full site reduction form. So first we start with what we know. We have our date, our body, our DR, our zone time, approximate GMT is 22. So this is a very late evening sun, or not evening, but GMT is late in the day. It was at 15:30. I was like, why did I do that? Okay, so that 10 is actually 22, right, from the chronometer. So we got a GMT date, 22/30/02, on July 31st, and we looked at the sun. So our first step of our site reduction form is to go to the almanac. Do I go to the almanac? I do. Okay. Oh, so I don't need to bring it up. Okay. So find July 31st in your almanac. This is going to be a little bit of a review. And we have our GMT time of 22:30:02. So we go to the 22 on the 31st, and we put in the GHA of the hour, and then we do the declination of the hour. And then I'm going to make note, there we go, make note of the D. Is it increasing or decreasing? Because I went from 58.2 to 57.5. So I'm going to be decreasing. So I put my little D there, was 0.6, and I know it's going to be decreasing. So that's what I get from my daily page on the Nautical Almanac. And then I have to go to the minutes and seconds to get me the next step. So that's going to be, because my hours are 22:30:02. So I'm going to go to the 30 page of the minutes and seconds, and then second 2. So I'm in 30 minutes, 02 seconds. The correction for my GHA is going to be 7 degrees, 30.5 minutes. I can plug that in right there. And then my little d, I go in with little d as 0.6. So my value was 0.3. Oops. My value was 0.3. So I'm going to subtract 0.3 from my declination. So now I apply my corrections, and I get a GHA of 55.2, and I get a declination of 1757.9. So now I need to come up with a assumed longitude. That way I can get an LHA and assumed latitude. Let's see. So calculate assumed longitude and assumed latitude. So here I had a GHA, I'll go back. I had a GHA of 155.2. I know I'm in the Western Hemisphere because of my DR. My DR up here is 110.15 degrees west. So I am going to, because I'm subtracting and I want this as a whole degree, I'm going to automatically put in 55.2 minutes. So I'm putting in 55.2 minutes, and then I have to decide what is the degree on my assumed longitude. Is it 109? Is it 110? Is it 111? Trying to see what am I closest to. So I was at 110.15. So I would be closest to 109 if I had to have the minutes 55.2. So if it was 110, 55.2, or 111, 55.2, the 55.2 has to stay there so I can get a solid whole degree for LHA. Now, if you do the wrong one, if you're not closest to it, it does not matter. The calculation will just give you a bigger intercept, and it will take into account the difference. You're just going to have a bigger number someplace else if this number isn't smallest. So it's not the end of the world if you don't get whatever one's closest. If you just go with the, because we're at 110.15, if you just go with 110, not a big deal. Technically 109.55 is closest to 110 versus 110.55. So I'm gonna have a small number, but does that make sense of how I got my assumed longitude? Where's my peeps here? Now, we're gonna practice this in our homework, but if we are adding, if we are in the Eastern Hemisphere, we have to add whatever numbers will get us to a whole degree. So in this case, it would have been 4.8 degrees, 4.8 minutes. So whatever degrees, 4.8 minutes, so I can get to that whole degree. That's my goal, is the whole degree. So your assumed latitude, or your assumed longitude, is getting you to the whole degree. So then we have a calculated LHA, and we have calculated assumed latitude by going to the whole degree. So my DR was 2212 north. So I'm just going to go to the nearest latitude, which would be 22 degrees. If it's 2230 and up, you can go to the 23 degrees. Same thing with assumed longitude. If you go to a different one, it will calculate the correction itself. It doesn't have to be like, oh, I got the whole thing wrong because I chose the wrong assumed position. All that matters is that it's a whole degree and that it will fit on your plotting sheet or your chart. So, and this is 3 degrees, which is what, 180 miles. So you'll be all right. Okay. So now we have the 3 values that we could go into Pub 229. We have LHA, latitude, and declination. My LHA and latitude are in whole degrees. So the only thing that I'm interpolating is my declination. So I'm just interpolating on the declination side. So that makes it easier. So let's find our LHA of 46 degrees and a assumed latitude of 22. So let me go to shoot, what was my LHA? LHA was 46. So I'm going to find 51, 42. 46. So I'm on page 94. Now that doesn't work. Does anyone know why? Oh. I'm in the wrong book. That's why.
I got all excited. I thought I had the right book, but I have the wrong book.
Okay. What I wanted to say, this is an old book, but I'm pretty sure it's the same here. I have 46 LHA for 15 to 22 degrees. So if I'm at 23 degrees, that's in the second half. So the first half of the book is 15 to 22. The second half of the book is 23 to 30. So if you find your 46 LHA, here's our 46, our 46 LHA for the higher degrees of latitude. And then we have our 46 LHA for the lower degrees of latitude. So if you found one, but then you can't find your latitude, switch to the other half of the book. Okay, so we had our LHA of 46, and then we have a latitude of 22. So we're going to be working in this column here. And our declination was 17. So we're going to go down to our 17. And I'm going to go back to the PowerPoint so you could actually read it. Okay, so we have our LHA was 46 degrees. Our latitude was 22 north. And our declination was 57.9 north. So we are going to be on the same side. So that's going to be the left-hand side. Forgot to say that. We're going to be in the 22 column. And then we are going to be on our declination. We are 17 degrees and then almost 18, right? So we're 17, but very close to that 18. So as we interpolate, we know that we're going to be in between these two numbers on this table right here, if you will. So let's plug these numbers in. Oh, good, I have it. Okay, so we have HC for our 17, the whole degree for declination was 17. So we had 17, 30.4, and then our little d was adding 14.3. So we're going to put that in right there. And then we're going to get ready to interpolate, but I'm just plugging in our numbers here. Our z for our 17 was 88.1, and then the next z for 18 degrees was 86.7. So I know with my declination of being 57, I'm going to be pretty close to that 86.7 number. But we will do the math to calculate exactly what it will be. So this is our math here. Why didn't I put it on here? Did I do it? No, okay. The declination was 17 degrees, 57.9. So I am 57.9 60ths working my way down this table. So I put in my calculator, 59.7 divided by 60, and then I multiply that by the little d, or my difference between the two HCs at the declination intervals. And I get my correction of plus 13.8. And then I can apply that correction, and I get my calculated HC. I do the same type of thing with my azimuth. I get my Z, which was my 88.1. My next Z was 86.7. So on this one, I have to calculate the difference myself. It doesn't give me a D, but we can do it. We can plug it into our calculator. And I can get that the difference between 17 and 18 was minus 1.4 degrees. So then if I times it by my ratio of the declination, which was 57.9 divided by 60 fraction, I get minus 1.35 degrees. So I minus that from my my base, from what I started at, from the 17, not from the next Z. So that can kind of be confusing on this formula, if you will. It is from, I know I have to be in between these two numbers, and I'm slightly more than the bottom one. So that makes sense with the mental interpolation. So you're subtracting this number from the Z. And then we have to convert our Z to Zn. So we are in the northern hemisphere. So we use the rule at the top that says LHA was less than 180. So my Zn is going to be 360 minus Z. So I have 360 minus my 86.5 gives me a Zn of 273. Okay, let me go back to this step. This was our interpolation step.
Quick question.
Yes.
You've got two significant digits there. And I'm not sure I see that precision in the tables.
Are you talking about the minus 1.35?
1.35 and then Z is 0.75, yeah.
Yes, you don't need that precision. I just, because of the example, sorry, because of the example that I chose, I would have been 1.4, but 1.4 was our difference. So I wanted to show you that it was just shy of that 18 because we were at 57.9.
Got it.
So no, you don't have to be that accurate. I was just showing how it's a little bit shy of it because of the example. So we didn't just go with what 18 was, that we do have to interpolate on the declination. Did everyone kind of follow along with the interpolation steps?
Yeah.
Okay. Sorry about my dog. Okay. So to complete our site reduction, we have our HC, which we just calculated, and then we put in our HO, which is actually up at the top, which we didn't actually calculate in this one, but I guess I already did. So our HO had those corrections from the almanac, from our apparent altitude. So we went from Sexton altitude to apparent altitude to observed altitude, our HO. So we just put in our HO again right there. So then we could see, oh, again right there. So then we could see the two numbers close to each other and get what the difference is. So the difference between our two HO and HC is 11.4 minutes. And there are 60 minutes in, or 60 nautical miles in a degree of latitude. So our 11.4 minutes is equal to 11.4 nautical miles. And then we have to put a a label on it. Is it away or towards? And that's saying which one is greater, the HC or the HO. And that is my HOMO-TO. Has anyone heard of HOMO-TO before?
Yes.
Okay. So if HO is more, then it's going to be towards. So you're going to be going towards whatever azimuth you've come up with. And that will make sense when I show you the plotting. So if HO is less, then it's going to be the opposite of that. It's going to be away from the bearing of the azimuth. So it's either towards the azimuth or away from the azimuth. We learned this one because I went to the California Maritime Academy, which is CMA. So if the calculated is more, it's away. Has anyone have any other memory aids? Most people use HOMO-TO.
I've heard CGA, calculated greater away, Coast Guard Academy.
Coast Guard Academy, okay, yeah. Cool. That's funny, I haven't heard that one, but it's the same concept of CMA. Okay. So we've calculated our intercept, we've calculated our ZN, and we've calculated our assumed position. So now we go, now I'm at the side. We have our assumed longitude, assumed latitude, then we have our ZN and our intercept. So now we can plot. So let me go through this one, and then we're going to go start our plotting, or start how to doing our plotting sheet. This plotting sheet is already made up because I already did it. But I have plotted my position. They gave me a DR, and they gave me a course, and I put some DRs in there. You don't have to, but you can. They gave me a course and speed, so I can put in DRs. My first step is to plot my assumed position. So my assumed position was 22 degrees north. So I'm going to be on a line. Every assumed position is on a solid line. And then your assumed longitude is the longitude so we can get LHA as a whole degree. So that's going to be, in this case, we were at 109.55.2. So here's 109.55.2. That's where my assumed position is. Oh, I've tried to make the picture lighter. Then our next step is to plot our ZN. So here, Ted, you can see I just made it 273, was my azimuth, and it was towards. So from my assumed position, I'm going to draw in my azimuth, which is going towards 273. Then from my assumed position, I'm going to put a little dot where my intercept is, or little a. And in this case, it was 11.4 nautical miles towards 273. So I drew in my 273 line, and then I put where my intercept is. Then I draw a line that's perpendicular to my intercept, to my azimuth line. This case, it's very close to vertical because I had 270, but it won't always be like that. Let's see, what else do I want to say on this one? Any big questions? Can I answer some questions from you guys? Can we get into the document camera?
So you're somewhere on that 1530 LOP.
Yes, and you can see the 1530 LOP is pretty far off from my 1530 DR position. So, I mean, what am I gonna say? Probably 5-10 miles, but 5-10 miles could be depending on where you are, right? If you're in the middle of the ocean, if you're within 20 miles of where you think you are, great. If you're closer to Hawaii and you maybe should be within 5 miles. So it's all dependent.
Relative.
It's all relative. Yeah. But if you get another sun line or another star line or something else, the more LOPs you have, the more accurate your position is going to be. Then the more accurate your DRs will be after that. So you're just building on your knowledge to really get an idea of where you are. So I want to go back to, hold on, I'm going to stop this share. Go back. To the PowerPoint. Nope. Okay, so I'm going to go back to kind of this little review on all of the things, how we get our assumed position, right? So our geographic position of the sun or whatever body we're looking at, we are getting a ZN or a bearing to it. And on that bearing, we've had an assumed position. So it can be here or it could be over here. It could be either away from our LOP or towards our LOP. And then this big circle is our LOP. And it's so big that we draw it as a straight line that is perpendicular to our ZN line. So that's why we do that perpendicular, because our actual line of position is a circle, or it's the circle of equal altitude, that if the sun is such and such altitude, you are somewhere around it as a circle of equal altitude. So plotting that assumed position and then calculating your intercept gives you that LOP, which we draw as a straight line. Okay. Let's stop share again. Okay.
I have a question. Would you do the same thing as you would do in coastal navigation then? You have your one LOP and you have your DR, and you do a 90-degree off the LOP to the DR to
Yes.
Get your estimated position?
Yes, that's what you would do to get estimated position.
Okay.
Now, ideally, you can do, and what we're going to do, we're not going to be moving, so it's going to be a little bit easier for us. But you get about an hour. You want your bearing. You know how in coastal nav we want not less than 30 degrees from each aid to navigation that we're using.
Right.
So same kind of thing with the sun, or as we're shooting it, you want it somewhere, you know, on the horizon here, and then somewhere on the horizon here, and then somewhere on the horizon here, and so forth. So I like to say at least an hour in between, so you get more of a spread on your lines. So as the day continues, that line that we're going to draw is going to be, the bearing is going to be different. So you get a more angle of the line.
And then are you advancing the
Yes.
line of position? Okay, I got it.
Yes. So then, depends on when you get it. You could bring it back to, say, the 8 o'clock. So just advance all your lines to 8. So you can get an 8 o'clock fix. Then you can get a noon fix using your LAN, the local apparent noon. Then you could get a 1600 fix by advancing all your lines to 1600.
Got it.
And then you can get your evening stars at, 1800.
Right. Okay.
Something like that.
Yeah.
Okay, so how are we doing so far? We don't need a break yet, do we? Okay. Get over to. Okay, so this is our universal plotting sheet. You can, use a chart, use whatever you want. I find the universal plotting sheet is a great tool to begin on because you just get the basic information. You're not distracted by everything else. So has anyone ever used a universal plotting sheet before?
Not me.
Okay. So now we are going to learn how to use a universal plotting sheet. I'm going to go off of our homework for number 1. Number 1. There, we are practicing doing universal plotting sheets. So it is telling us our mid-latitude is 30 degrees north. So I'm going to call this one 30 degrees north. And then it told us our mid-longitude, which is going to be our vertical line, was 130 degrees west. So I have try to get it dark on there so you can see it. So 130 degrees west is the longitude, 30 degrees north is our latitude. Then it gave me a DR and a course and speed. So from getting my mid-lat and mid-long, I need to then plot out the rest of my latitudes and longitudes. My latitudes are already here for me.
Sorry, Bree?
Yes.
Quick question. When you say mid-latitude and mid-longitude, don't you just kind of take a look at your DR and see which are the closest latitude and longitude?
Yes. Yes.
Okay.
So I'm just giving you guys a mid-lat and mid-long, but you're just ballparking where you are on your DR.
Got it.
So if this is 30 degrees north, this would be 31 degrees north. This one would be 29 degrees north. My latitudes are already in there. Now we have to plot our longitude. So there's 2 ways to do it. I'm going to show you both ways. You can see the numbers on our compass or circle here. We have the compass where it's 0, 10, 90, 180, 270, 360. But then we also have numbers just on the right side where it starts as 0 at our latitude and then 10, 20, et cetera, going up. So one way to do it is we are at 30 degrees north. So I'm going to put my pencil at 30 degrees. This is 10, 20, 30. So here is the 30 degrees that I'm doing. So if I put my pencil on both points, I can draw in a longitude line for my 30 degrees north. One more way to do it. Maybe this is a better way. I just wanted to show you that way too. Let's look at this longitude scale at the bottom. So our latitude's already on here. And then down at the bottom, we have our longitude scale. And our latitude, it says mid-lat was 30. So I'm just going to bold in that line so we could really see it. So I am working somewhere on this line because it's my 30 degrees north, 30 degrees mid-latitude line. And then this will be my longitude scale. So if I want to get 60 degrees of longitude, because this is my 130, and I want to get what 129 is, that's 60 minutes of longitude. So I'm going to go from the edge to the edge. No. And get 60 degrees of longitude, which is right where I am there. So in this case, you could just make a little mark like this, make a little mark. And then I can put my pencil there and draw in my next longitude line. And now that I have my 60 minutes, so my whole longitude, I can draw in all of my lines. So now I've drawn in all my lines. And I can even come up here and do 32 degrees north. If this is 130, this would be 129. This would be 128. This would be 131, 132. Okay. Did everyone follow how I created that? Okay. We're going to do another one too, but we're going to build from this. Okay, so now I have, you know, a pretty large piece of the world here. I have, yeah, this is 28 degrees north. 29, 30, 31, 32, and I have about 4 degrees of longitude. So I have a wide area here, and I need to plot my position. So they gave me, in my problem, 0800 DR was 30 degrees 20 minutes north, 130 degrees, 40 minutes west. Course was 60 degrees true. Speed was 12 knots. Okay. I just wrote it down real quick. So in order to plot my latitude, I'm going to be at 30 degrees, 20 minutes north. So I'm at 10, 20. So I could draw in my latitude. I am somewhere on that line. This is a latitude line going all the way from 130 to 131. For 30 degrees, 20 minutes north. Now I go back to use my longitude scale. I'm going to use my compass on this one. So my longitude scale if you could see, it starts at 50, 40, 30, 20, 10, 0, and then another 10. So that's how, if you got a total of 60, that's how we did our longitude. Now I want, what do I want? 40 degrees. So if I wanted 42, I could go right there, but I want 40 degrees. So I'm going to put my divider at the 0, and then I want to get it to where it crosses the 40. So I'm going to use my compass and say that's my 40 line. Now, if I was doing more than 40, I would start at the 40 and then go, 42, 44, 46, somewhere along the line there. But I'm at 40, 0. So there's my 40. If I plot that, it's going to be from 130 going west, because I'm at 130, 40 degrees. So here is my DR. Now I'm going to plot my course and then put a little symbol on it. My course was 060. So same as always. You can do 060 many different ways. I'm going to use the triangle. Okay, so I'll plot my line. And I have a DR of 0800. I have a course of 060 and a speed of 12 knots. And then I can erase the extra line just to clean it up a little bit. Now again, using universal plotting sheets, you don't have any, an island is going to be right here. The island's not on the map. We're just creating a tool to figure out where you are, and then you could put that on a chart or adjust your course if you have a destination in mind. Okay. So, any questions so far? Okay. So this book,
I'm sorry, Bree, quick question.
Yeah.
So obviously I saw how you slid over to get your 60 degrees on your course. You're going to do it a different way in the next example?
here, let me do it. Roll plotter, you can use that one. So I can do 60 degrees.
Okay.
I like to use the black line there. So I have the black line crossing through the center and then crossing through 60. Put my pencil on here, bump it up, and draw your line.
Okay, thanks.
Yep. Who uses triangles? Who uses roll plotters? Okay, who uses
I've got both.
parallel? Anyone do the parallels?
No, not me.
Let's do the parallel too.
I think most of us do the roll plotter.
Yeah.
Triangles.
Okay. I'll do both of these. That way you guys can see us doing both. Okay. So this is how to set up your plotting sheet with a DR course and speed. Now I'm going to skip on the homework to number 4, and we're going to plot an LOP. So number 4 told us, I'm just going to write it on here. We have an assumed latitude of 31 degrees. We have an assumed longitude of 129, 23.3. We have an intercept of 7 towards, and we have a ZN of 224. Okay. So now I want to plot an LOP. I have my DR. The first step is to plot your assumed position. So again, this isn't where we think we are. This is how we calculated our intercept. So how we've calculated our LOP. We have it a whole degree. So my 131 degrees north, I'm going to be somewhere along this line. And then my assumed longitude is 129, 23.3. So I am going to use my longitude scale. So this is my 20, and this is 2, 4, 6, 8, 10. So I'm going to be in between the 2 and the 4, finding my 23.3. So I'm at 20. See if you can see it here. Bring it down. 22. All right, I'm going to say that is my 23.3 degree, or yeah, 23.23 minutes from my 129. So I go to 129. I'm on the 31 degree north line. And I can plot this right here is going to be my assumed position. So now I have an assumed position that I can take a bearing and a range from, essentially. So I have assumed position. Now I'm going to plot my ZN, which is my bearing. And I know I'm going towards it. So I will use my roll plotter here to find 2, 2, 1. 2, 1. So I have 2, 2, 1, and then I'm going to parallel that over to my assumed position. And sometimes people put this as a dotted line, but you can put it as a solid line if you want. You just don't want to confuse it as an LOP yet, or ever, really. Because this is our azimuth, our LOP is going to be perpendicular to that line. Okay, so I'm actually, there we go. So that is my ZN. My next thing to plot would be my intercept, and that's going to be 7.0 nautical miles towards 221. So if I'm going towards 221, I'm going to be going this way, and I want 7 miles from my assumed position. 7 miles, just like on a chart, you have 60 miles in a degree of latitude. So your scale in the middle here is also a distance scale, just like latitude. So if I find 7, there is 7 nautical miles. Now I'm going to put that from my assumed position. Make a little mark. And now this is where I like the triangle because it has a perpendicular thing already in it. But now I'm going to draw in from that intercept. That's going to be the intercept line there. Put my pencil in the intercept and draw a perpendicular line to the azimuth. So that is my LOP. I'm somewhere along that line. I don't have a time for this or anything, so I don't know if it's a noon or an evening. I don't have a time for the LOP for some reason, but that's okay. So we do that all again for another LOP, and we want minimum of 2. 3 to 4 LOPs would be best. Any questions? Kind of following along?
Yeah, just the towards and away part.
The more or towards or away is towards or away from the DR. Is that correct?
Towards or away from the assumed position.
Where do you start then?
So if this one was 7 away, we have our 2, 2, 1 going away from 2, 2, 1. So we start at our assumed position and we went 7 nautical miles towards 2, 2, 1. If we were going 7 nautical miles away from 2, 2, 1, it would be right here. And then we would
Wait, no. Hold on, Bree. When you say towards 2, 2, 1, you're going along 2, 2, 1. You're not going towards or away from it. That dotted line is 2, 2, 1, correct?
Correct.
So you're going along 2, 2, 1. You're not going away or towards it. You're going away or towards the DR, correct?
This DR?
No, you're going toward the 221 on the scale.
The 2, 2, 1.
So even if you're down here, you're just like, if this is your assumed position, so let's call, our assumed position, okay, they're always on a line. Here's our assumed position. New one right there, right? If we were going towards, if we were here and I wanted to draw a line of 2, 2, 1, it would be, generally speaking, this way of 2, 2, 1, going towards 2, 2, 1. This way.
Oh, I see what you're saying.
Would be from my assumed position away from the direction of 2, 2, 1. Would be over here.
It was a 180 minus 2, 2, 1.
So Bree, hypothetically, what if your assumed position is right at the edge of the scale of where 221 is? Are you going toward or away if your AP is right on the 221 line?
You're talking about this circle, you mean?
Yeah, so you're going toward 221, correct? So
yeah,
coming.
So like in this one, I'm not, no relation to what the scale is doing. I've plotted an assumed position, and then my 2, 2, 1, let's see. I've created a 2, 2, 1 line, and then rolled it over to my assumed position, and can draw it in. And then if I'm going towards it, it would be towards 221, or away from it would be the reciprocal, 180 of it.
Got it. Has no relationship to the scale on the plot sheet.
Nope, you can get 221. It's just, you know,
I'm
north,
with,
east, southwest.
I'm with, got it.
Yeah.
Okay.
Okay. So now we're going to do this again, and we're going to plot 3 LOPs. So I'm going to do number 7 on your homework. Okay. Let me put this under so the chart doesn't get. Okay, so do this one along with me. We want to take a quick break first. That's 8. Yeah, I usually take a break at 8. Okay, let's take a 5-minute break and come back at 8 o'clock. Keep on recording. Okay, so we have a blank plotting sheet, and we're going to do number 7. So number 7 tells us at 1800, we complete a few site reductions and get the assumed position for each star and our intercept and our azimuth. So we're going to plot all those assumed positions and the LOPs. They give us a hint. We're going to start with our mid-latitude was 28 degrees north, and our mid-longitude was, I don't know why there's an A there. I guess it should be a 0.
Should be 1 for 162
Yes,
degrees.
it should be a 1. Thank you. There we go. 162.
Yeah.
162 degrees east. So we start with putting in our longitude lines. We are at 28 degrees north. So I'm going to do this method this time. So we have 20, 25, and I'll call this 28 degrees. So I made a 28 degree mid-latitude line. Then I'm going to get my 60 minutes of longitude. And put in my longitude lines. Okay, so I have my longitude lines. This was 162 east, so I have 163 east, 164, 161, and 160. If this was 28 north, I have 29 and 27. So I have set up my plotting sheet. In this question, they did not give us a DR with course and speed. We just have assumed positions and intercepts and azimuths. So I think I'm going to do each one individually. I think that would make more sense. So our first assumed latitude is going to be 28 degrees. So I'm going to be somewhere along this line. My assumed longitude is 162.33 east. I'm going to go 30, 32, 33, be right about there. So I have 162.33 east. So this is my assumed position, and I might call it 1 or 2 or 3. I don't have 1, 2, or 3 on here, but this is my assumed position for the first part of the problem. Okay, then my next step is to plot my ZN, which is 135. I'm going to find 135. And put it through my assumed position. So 135 is going this direction from my assumed position. Now my intercept was 6 miles towards. So I'm going to find 6 miles and go towards 135. So from my AP, I'm going to go towards 135. Six nautical miles. And then I'm going to plot a perpendicular. So this is my my intercept. I know it's really small. Perpendicular line from this point. Oh, let me get real pencil.
Now, from a process standpoint, would you label that with the time of the site?
Yes, I label it with the star or the time of the site.
Got it.
I don't have that in my problem for some reason, but yes, you always want to label your LOP. And you can erase everything else. You don't have to keep your assumed position or your ZN line on there. If you want to go back to check something, it's great to have it on there. But when you start getting lots of little assumed positions and azimuth lines, it'll be confusing. Okay. Everyone follow along that first LOP? Okay. So our second LOP here has an assumed position of 28 degrees and then 161.52 east. So I'm going to find 52 east. So I have 50 and then right on that 2. And that was 161.52 east. So this is my assumed position 2, if you will. My next step is to plot the ZN. I have a ZN of 0.75. So this is my ZN in the direction of 0.75. And then I need to plot my intercept, which is 20 miles. So this is my A for intercept. And now I want to draw a perpendicular line through that A. So that is my second LOP. I had the assumed position, my ZN, and then my intercept. Am I going too fast?
Nope.
Okay. Okay, so our third one, we have an assumed position of 128, same latitude line, 162.20. So let's find 20. On that one, assumed position 3. So I just plotted my 20 degrees longitude line. So that's my assumed position. My azimuth on this one is 10. And in this case, it's away from 10. So if I find my 10 degrees, instead of going towards 10, I'm going to go away from 10 because it's also 10 miles, but it's 10 away. So that's essentially, 190. See, this isn't going to be an exact triangle, but let's see what happens. Or exact pinwheel, which I thought it would be. Oh, it is not. So here is my intercept. And there is my LOP. So I think I made a mistake somewhere. Did anyone catch my mistake?
It was looking good to me.
It's not a pinwheel. I did make this up a while ago.
I did notice that your longitude lines aren't really lining up right.
My longitude line.
They're going more 35 degrees rather than 38 degrees. I'm not sure how much help that's going to be, though.
$28 degrees
Or,
north.
sorry, 28 degrees. 25 degrees instead of 28 degrees.
You used 25?
I'm looking at your lines there, and it looks like they're going through the 25 degree mark on the compass rose there.
Oh, yeah.
So, but I'm not sure how much that's going to change things.
Wouldn't change things too much. Let me see.
Yeah, I don't think we measured anything off of that longitude line. Six, 20.
So basically, that triangle is about 8 miles.
Put it out.
You could be off about 8 miles or so.
I did a typo.
Oh,
I was like, I know I did this one. See, my assumed position number 3 is 161, 20 degrees east. On my homework, I have it as 162.
oh.
One little thing can get you real twisted. So if we replot that, this is a little bit better longitude line. As our 20 minutes from 161, we get our assumed position to be over here, and then we get our 10 miles perpendicular line gets us a solid fix.
So I guess I'm lost. The assumed position 3 should be
Assumed position 3 is 161.
I see. Okay.
Where was it on the other one? On the one you just
It
did?
was 162.
Okay.
So it's somewhere over there.
One.
You went away on that one. I'm sorry.
What was that?
And then it was away rather than
And it was-
towards on
yeah.
that one.
So we plotted our new assumed position, our corrected assumed position, my mistake. And then our ZN was 110, but we plotted it away from 110. And then this was our 10, which is our intercept. Did I mess you guys up a lot?
Yeah,
Yeah.
that's okay.
Ay, ay, ay.
Yeah, can you,
Do
can
we
you
want-
show us the one you just did?
Just go-
Yes.
Okay, I see where it is. Got it.
So this guy should be over here.
So just move the LOP down a little bit.
What?
Move the LOP from the assumed position number 3 just down a little bit so it hits the center of the other
Yeah.
two.
We won't tell the captain.
Yeah.
Yeah.
But this is a big triangle. So right off the bat, I was like, nope, I did something wrong. Like red flag.
Did I see the Concordia up in the upper right-hand side there?
If you're 300 miles offshore, that looks fine.
I will fix the homework and repost that tonight.
Yeah, no, this is actually good to say, okay, wait a minute, there is something wrong. Let's
Yeah.
go back and recheck because
Yeah.
you know those 3 lines have got to intersect.
Yes. Or be close.
Closer than what you were there at the first one.
Closer than that. Yeah.
Got it.
And essentially, in all of these problems that I've made up for you, they cross like this. So if they don't cross like this in my created problems, then either there's a typo on my part or an error on your part. So you keep that in mind. But when we do it in practice, when we do the sun lines on the pier and the stars, you'll get to see, you know, how how each individual's numbers are different, whether it's your number versus my number versus, you know, Tim's or Robert's or Bill's, whatever it is. They might be a little bit different, and that's okay. Okay. I'm bummed I made this mistake. Let's, yes.
You kind of, in your earlier part of the discussion today, you kind of glossed over how you enter 229. I was wondering
Okay.
if you go back over that.
Yes, so our number 8 of the homework assignment is calculating our assumed position and how we go into pub 229. So now we're going to go back to the pub and start calculating things. Now that we've practiced a little bit of plotting. So we'll do at least the first 2. And then we'll do, the next page is pub 229 practice. Okay. So, our number 8, we start off with going back to our Nautical Almanac. So we are starting with the Nautical Almanac on April 13th. And these are all going to be the sun. So keep that in mind. th at 1800. Let me see if I can. Okay, so we are 18, 15, 23. That's our time. So we go into our nautical almanac. A little bit better there. Okay. 1300, or the 13th at 1800 gives us a GHA of 8954.7. I'm gonna write that in. 89 degrees, 54.7 minutes. And then I need to go to the minutes and seconds. We have 15 minutes and 23 seconds for the sun. That gives us 3 degrees, 50.8 minutes. 3 degrees, 50.8, excuse me. So then on my calculator, I can figure out what my GHA is. And I got 45.5 and 0.93. All right, so now I need to get what my assumed longitude is. So my goal here is to have my LHA as a whole degree. So I don't have to do that triple interpolation. So this is my DR longitude, is 121.33 west. So if I'm west, I'm going to be subtracting. So to get it to a whole number, I have to subtract 45.5 minutes to get my LHA to a whole degree. So now I need to decide what is my degree part of my longitude? What is closest to ending in 45.5? In this case, it would be 121 degrees, 45.5 is closest to our 33.3. So now I can get a LHA. 121 gives me 332 degrees, whole degrees, because it's 0 minutes. So I have an LHA of 332 degrees. My longitude is this guy, which was 121.45.5. And then I need to get my assumed lat. So here I'm looking at my DR lat and saying, what's the closest whole degree? So I'm at 3720. So my closest whole degree would be 37 degrees north.
I have a question. I thought we were supposed to subtract the longitude because it was west. Did I miss something?
Yep. So it was 45.
Okay.
Oh, so you can't subtract 121 from 90.
Oh.
So you did 93. Oops. Can you see my calculator here? So 93 plus 360 to make it a big number.
Got it.
And then subtract 121 and you get 332.
Okay. Okay. I missed a step. Okay. Thanks.
Yep. Okay, did that make sense in creating our assumed position? Okay, so let's try the next one here.
Okay.
Oops. Whoa. All right.
I'm sorry, Bree.
Yes.
I've got the how you got the assumed latitude. The assumed longitude is what? Or is that just LHA?
The assumed longitude
Yeah.
was what we created. We created an assumed longitude to get our
Okay.
LHA.
Got it. Okay.
My screen split for some reason.
I just have to label it that way.
Are you guys seeing like a split screen? Okay, whoa. Okay, now you guys can see the document camera, right?
Yes.
Yeah, okay.
Yes.
So, yes, Ted, we created that assumed longitude because we had a GHA, that's what we calculated. And then in order to get a whole degree, and I was minusing, it had to end in 45.5. And then whatever is closest to my DR. So I did 121, 45.5.
Yeah, I just didn't catch the label on that. Got it.
Okay, so then we got May 20th, number 9. We have a GMT of 01, 45, 15. So 01 gives us 195, 51.8. Okay, and then we go to the minutes and seconds, and we are at 45:15. So I have a minutes and seconds of 11 degrees, 18.8 minutes. We add those up. Oops, there we go. 1.8 plus 18.8 gives us 9.6. So we have a GHA of 207, 10.6 minutes. And we are in the west. So again, I'm going to be subtracting. So I know that my assumed longitude is going to be ending in 10.6. And now I have to decide what is closest to 155. Is it 155, 10.6, 154, 10.6, 156, 10.6? It's 155 again. I'm sure I'm going to come up with an example where it's the opposite. Yep, okay. So my assumed position is going to be that 155, 10.6, because this gives me 0. And then to put in this number, I get 207 minus 155 gives me 52. So I have an LHA of 52 degrees. I have a longitude of 155 degrees, 10.6 minutes west. And then my latitude, my DR latitude was 2245. So I'm going to say my assumed latitude is going to be 23 degrees north. That's what I'm closest to. Now again, if you put 22 degrees north, that's fine. You're just going to have a bigger intercept. So whatever you use, your assumed, you know, these are the three things. Well, they're not the three things, but your LHA and your assumed latitude are the two whole numbers that you go into the Pub 229 with. So you're just computing an altitude for an assumed position. That's essentially what you're doing. Okay, any questions so far? Our next one's east. So we're gonna figure out how to do an easterly one. Okay, so we're doing the sun. We're on November 25th. We have a GMT of 03:34:52. November 25th, we have a GHA of 228 degrees, 14.9 minutes. And then we have to go to our minutes and seconds table to get 34. 34 minutes 52 gives us 8 degrees 43.0. We add those up, we get 0.975 and yes, the 236. 236, 57.9 is our GHA. Now, because our longitude is east, we are going to be adding it. So we are adding it this time. So what do I need to get this to a whole degree if I'm adding? I need 02.1 minutes. Everyone see where I got that 02.1? It's basically 60 minus this will give me, so now I have a whole degree in LHA because I'm adding. I had 57.9 and I needed to get to the whole degree. So I'm going to add 2.1 and I get to 60, which is a whole degree. So now I have to decide, is it 151, 152, 25? I'm going to say it's still the same. I'm going to go with 150. So now when you're adding this, you have to keep in mind this is equal to 60 and you have to carry that 1 on the degree side. Make sure you remember to carry that 1. So we have 236 plus 1 plus 150 gives us 387, which doesn't work. We have to subtract 360 from that, and we get 027. So our LHA is a solid degree as 027. Our assumed longitude we've created as 150 degrees, 02.1 minutes east. And now we're going to look at our latitude. We have 15 degrees 35 south. So 35, we're going to round up to 16 degrees south. Any questions on the east and how we got an assumed position using east? Okay. Okay, let's do number 11. August 15th of the sun. All right, so we're at August 15th. Our time was 14:20:09. August 15th is 28:54.5. degrees, 54.5 minutes. Then we go to minutes and seconds. We find 20. .09 gives us 502.3. Okay, so we add that up and we get 856 and 033. All right, yep. So we have a GHA 33 degrees, 56.8. We are again in the west, so we're going to be subtracting. So I know my longitude is going to be subtracted. So to get to 0, I'm going to subtract 56.8 minutes. And now I need to decide what that is closest to. So I have 079, 15.8 is my DR. So if I'm ending in 556.8, here's 79 degrees west, 78 degrees west, 80 degrees west. Oops. So if my DR is somewhere along this one at 15.8, but I need to end in 56, that's essentially this one or this one. The closer one would be 78.56. So I'm going to call my assumed latitude 078 degrees. My 56 gets to 0. We do 33 plus 360 minus 78 gives us 315. Whole degree. So then my longitude, I know I'm sloppy here, gives us 078 degrees, 56.8 minutes west. Our assumed latitude, we're going to round to the nearest. We're at 24.2, so we'll round down to 28 degrees north. How do you guys do on that? Make sense on creating that assumed position?
Yeah.
Yeah.
We just want to get the LHA to a whole degree and latitude to a whole degree, so we don't have to triple interpolate. And now we're going to practice interpolation. Back to 229. Okay. So on, I'm going to try to see if I can go back and forth here. Oops. Okay, so for number 12, we're just going to do one at a time here. Number 12, we have an LHA of 283, and we have a latitude of 22 degrees north. So I'm going to be in that volume 2, where it's 15 to 30, site reduction table. And then I'm going to find the first half of the book goes from 15 to 22. So I'm going to be in the first half of the book, and I'm looking for an LHA of 283. So I'm going to flip through the beginning of these pages. There's 297. Looking for 283. Oops. 38, 37, 285, 4. All right, so here's our 283. So we have 283 on this side. Let me make this smaller, sorry. 283 for latitude, same as the declination, and then we have 283 for the latitude contrary to declination. Our problem, we have a declination of south and a latitude of north. So we are on the contrary side. We're going to be on the right side. So we have 283 whole degrees, so I know I'm somewhere on this page. And then I have 22, so I know I'm somewhere in this column. So I know I'm, get this. Somewhere in that column. Too many books on my table here. And then I have a declination of 1236. So I'm somewhere in between 12 and 13 on my declination. So that's where I need to interpolate. Interpolating using my declination between 12 and 13. So we're going to use our site reduction table and plug in our numbers and see how this interpolation works. Our first one, I'll put it here. Is our HC. So HC is at the top. So our HC for 12 is going to be 7 degrees, 14.8. I didn't put in this in, but we have LHA of 283, declination 12 degrees 36, latitude 22 degrees north. Okay, so did everyone see where we got this 7 degrees 14.8? Yep. Right track here, okay. Okay, then that D, we're gonna write it in, is gonna be minus, see that little minus sign there? Minus 24.9. So we're going to put in our little d. I'm just gonna write it minus 24.9. I'm gonna write it smaller. Okay. There we go. And then, while I still have my 299 open, I am going to write in my Z and ZN. So I had at 12, my Z was 106.1, and then my next Z, so the 13, was 107.0. And that's what I have for what I read from my 229 here. I'm gonna go back to my altitude corrections, and this is where we're going to interpolate. So from 12 to 13 degrees, because my declination, we subtracted 24.9 minutes. So I'm at 12:36. So how I interpolate this is I multiply 30, or I divide 36 by 60. So I have that fraction. It's 60% of the whole degree there. So 36/60ths times what it would take to move the whole degree. So 36 over 60 gives us 0.6 times our 24.9 gives us a correction of minus 14.9. So now we apply this correction to my HC. So I get 6 degrees, 59.9 minutes as my HC. You guys follow along on that one?
Yeah.
Yeah?
Yes.
Okay. So now we're going to do the same kind of thing for our azimuth, but they didn't give us the D, so we have to calculate that ourselves. So at 12, it was 106.1, and then at 13, it was 107. So the difference between that was an increase of 0.9. So they didn't give us that, but we can see that. We increased 0.9 degrees. Now I'm in between the 12 and the 13, right? This was at 12 and this was at 13. And I'm at 1236. So I'm going to multiply this by 36/60ths. So I'm doing 60%. And I get a correction of plus, because we're increasing, 0.5. Now I'm going to apply that correction to my base, to 12, because I'm 1236. So I have 106.1 plus my correction to give me 106.6 degrees. Does that make sense so far? We did another interpolation there. Our next step is to convert Z to Zn. This is where we follow the rules that are on our 229. We are in the northern latitude. So we have a latitude of 22 degrees north. So we are going to follow these rules here. We had an LHA of 283. So 283 is going to be greater than 180. LHA is greater than 180. So our Zn is equal to Z. So we go back to, okay. Our Zn is equal to Z. We don't need to change it in any way. So our Zn is 106.6. How are we doing?
Okay.
Okay.
Bree, do you really need 100 to do Z or Zn to the decimal degrees?
No. You could round it. It's all about, you know, you're seeing it on here. So you're trying to get 0.6 out of
Right.
something this big. So
Precision there is only 1 degree.
yeah. Yeah. If you're taking the Coast Guard exams, they round to the nearest tenth. Okay. Let's do number 13. Any questions so far? Okay, so on 13, we are at a latitude of 24 degrees. So I'm going to be in the second half of the book to get to my 24. And then I have an LHA of 326. So I'm going to find. Okay, so I have a latitude of 326, and I have, oh, excuse me, a LHA of 326 and a latitude of 24 on the same page. Now I need to decide if I'm on the right side or the left side. I have a declination of south and a latitude of south. So I'm going to be on the right side under latitude same as the declination. So I'm at 326 and then I'm at 24. I'm going to put my little marker here. Let's see if we can get this all on the same frame. Okay. So my declination is 22:15. So I'm going to be in between here. My 22 degrees, 15 minutes south. I'm in between these two. When I write this in, I'll start with my HC. So I have 58 degrees, 42.8. And then I have a D as plus 10. I'm going to put a plus 10 right there. And then my fraction of the declination is going to be 15/60. So I'm multiplying that by 15/60. So I have 15/60, 0.25 times 10 gives us a correction of plus 2.5. So if I have 42.8 plus 2.5, that gives me 45.3. So my HC is 58 degrees, 45.3. Okay, now for my Z and ZN. My Z here was 86.7. I'm going to put 86.7. Dang it. (86.7 degrees). My next Z is 84.8. 84.8. And then I need to figure out what my difference was. So I went from 86 to 84, so I'm going to be subtracting. And how much am I going to be subtracting? (1.9). So I'm subtracting 1.9 degrees, but I'm only subtracting 15/60 of that because my declination was 22:15 minutes. So I'm doing 15/60 times my 1.9. And that gives me a negative 0.5. So I subtract that from, because this was my 22 and this was my 23, I subtract that from my 22. So 86.7 minus 0.5 gives me 86.2 degrees. And that is my Z. Now I need to convert that Z to Zn. So I go back to my rules. This one was for the north latitude, but I am in the southern hemisphere. I'm at 24 south. So I'm going to be following these rules down here. My LHA is greater than 180. My LHA was 326, so my LHA is greater than 180. So my Zn is 180 minus Z. Write that in there. So I have 180 minus Z is equal to Zn. So I have 180 minus 86.2 gives me a Zn of 93.8 degrees, or 94 degrees. How's it making sense so far? All right. I'm going to let you loose, and you guys try number 14 for the next 5 minutes. Try it on your own. See how it goes. All right, how are we doing? Doing okay? Any big questions on 14, or did you get through it? These are our answers. Anybody get something different?
I used the correct table, no.
So which table did you make a mistake on?
I think, let's see.
Did you do contrary instead of same declination?
Yeah. Well, the other way around. I did same instead of contrary.
Okay, so you were on the wrong page.
Right, yep.
So another way that you'll quickly figure out if you're on the wrong page or not is if that HC is ballpark what your HO is. You've already calculated your HO. So that HC should be within a degree or two.
That makes sense, yeah.
Of what you're looking for. If it's completely not, then maybe you're on the wrong LHA. You know, time to go back and look at some more, just so you don't have to redo the whole thing from the start.
Right, okay. So I would have been off by 20 degrees, so that would have been the big indicator there.
Yes, yes.
Got it, okay. Makes sense.
Okay, well, The next part of the homework is a full site reduction. So we are approaching Hawaii, so we're still going to use that volume 2. And then we have a DR, we have a chronometer, index error, high divide, all of the details you need to do a full site reduction form, which is a lot of numbers. And I'm going to do this one by hand on video. So I'm not going to do it now, but I'm going to do the whole thing by hand and record it for the homework tutorial. I'm going to do the whole homework assignment again, basically. But that is going to be a lot of work on the homework. So please let me know if you come across a question or get stumped on something and have no idea where I'm coming up with the number. I'm going to be around all weekend, so shoot me a text, shoot me an email. Let me know if you get how you guys do on this. And also come back, you know, next week with some common mistakes. Oh, I kept going to the wrong table in 229, or I forgot I used time instead of declination for the interpolation, or whatever. You know, share with the class. That way we all can learn as a group to avoid the common errors, because we all make them.
Dee, I'm sorry, Bree, I have one question, final question. We interpolate for HC, but we don't interpolate for Z. Is there a reason for that?
We are interpolating for Z. Let me go.
Oh, actually, okay.
You're
You're right. I'm sorry. That is correct.
We're
It's just a
interpolating
different way.
Yes, because they don't give us that D. We have to create the D by itself.
Right.
Where the HC, they give us that D value.
Yeah.
Okay, well, that was a lot this week. Next week, we're going to learn a shortcut way to do everything that we did today. So look forward to that. So we're going to learn a quick way to get an LOP at LAN, which is local apparent noon, and a quick way to get LOP at by Polaris. If you shoot if you get a shot of the North Star, you'll get a quick way to get a latitude. So so those are great tools. Those are, if you have the opportunity to do a shortcut one, it saves a lot of time and energy. But again, we're gonna learn this longhand way, and then we'll do some shortcuts. We're also gonna do a lot of time work, figuring out sunset, figuring out sunrise, LAN next week as well. And then that's all of our, basically all of our learning that we're doing. We end next week, and then we'll do prep and lab stuff for the rest of the time. So we're coming along pretty good. Today was a big day.
Yeah.
How you guys feeling so far? Am I going too fast, going too slow?
So Bree, I got to tell you, 95-year-old dad who was in the Navy in World War II in the South Pacific, he's been following me with these classes. He is so excited that I'm taking these classes. And you finally got to the point that I can tell him next week. He goes, "Has she taught you the shortcut yet?"
That's next week. Next week.
Thanks. He'll be excited to know.
Shortcut is the celestial navigation calculator.
Yeah, that's also the shortcut. Yeah, plug it in the calculator. Cool.
Okay.
Well, Yeah, I'm excited. I think we're doing pretty good. And yeah, you guys can go out and practice, getting index error or shooting the sun with your sextant just to get a feel for it. We'll do that together. I did post those dates, so you can put those on your calendar. Yeah. Give me an email if you got any questions. That's all I got.
Thanks, Lee. Take care.
Thank you. Have a good night.
Have a good one.
Thank you.